This is quantitative data analysis techniques. This is assignment 4.5. This is part one. This is the theory section or organisation section. So the first thing I'm going to talk about is hypothesis. This is an important stage of your study because this is the prediction you will make about the results that you will collect at the end of your study, what will happen during your study when you've experimented and had your variables affect what you're studying, basically. So when you're choosing your hypothesis or making your predictions, you will either make a null prediction hypothesis, an alternative or two-tailed, or a one-tailed hypothesis. An alternative and two-tailed are the same thing. Sorry. So a null hypothesis is basically when you predict that nothing will change after your experiment or variables have taken their course in your study. So, say if you had a marathon run or a 100-meter sprint runner or something like that, and you gave them caffeine before a race, you could predict that nothing would happen, and that would be a null hypothesis. Nothing will change in their results. So, an alternative or two-tailed hypothesis would mean that you're basically giving no direction to your predictions and saying, so using the same example for the 100-meter sprint runner, you could say that caffeine may benefit his results, or it may have a negative effect on his results. And this is a two-tailed hypothesis because you're basically giving no direction to what the variable is going to have an effect on the results at the end. And this is basically the opposite to our one-tailed hypothesis, which basically you'd be stating or predicting that one thing would definitely happen. So if you gave caffeine to a 100-meter sprint runner, if you made a one-tailed hypothesis, it would mean you'd be saying either their scores are definitely going to get better, or their scores are definitely going to get worse. It's giving a direction to your prediction, so it's definitely going to go one way or the other. So moving on to quantitative data and the benefits of quantitative data analysis. So there are a few that have been listed here, which is the data you find from your studies is going to be numerical data. This basically means that you can do a lot more with the data you collect. So in contrast to a qualitative data study where the answers are a lot more long-winded and they're written, so it's more like an essay sort of question answer where it's thoughts, feelings, and opinions from other people, and it's less factual, it's more opinion based. It's harder to represent and also transfer into presenting data and comparing with other data than it would be with quantitative data, because quantitative data is almost always numerical value. So this means that you can. So this links directly to the next 2 points, which is normative data and presenting data. Having numerical data from your study means that you can compare it to the normative data, which has many benefits because you can spot anomalies if you have a whole group of people that are exceptional, and you find some normative data from another study and compare them and see that your class is much better, then this could mean another investigation into your study. If some other factors were wrong, if they were doing the testing wrong, it's important and it's helpful to have numerical data and compare it to the norm. So this is a helpful thing in your study. Another way is presenting data. With qualitative data, for example, you would not be able to present it in the same way you would be with quantitative data. With quantitative data, you can implement it into graphs, charts, and basically you can make it a lot easier to view and interpret. And when it comes to presenting your data, this is going to be much more helpful than and a lot more easier to present than other ways of collecting your data. And then another few benefits could be you can identify trends more easily because it's all numerical, so you can see quite quickly if there's an anomaly or an outlier in your data. And then obviously for sports, you can identify trends in health. You can make predictions. So say you can make predictions on sports performance because of the data that has gone before. So you can look at you can look at normative data, and you can suggest that this will be the data that your participants will produce, for example. So there's a lot of benefits to quantitative data. A few negatives are that you cannot. It is factual data, but it does not give the why to why it is like that. It does not give an explanation. And it does not give much insight to why the values are like they are. So moving on to organising data. So the first way of organising data I'm going to talk about is rank order distribution. So this is basically, as we see on the left side of my column, this is vertical jump scores. We can see the original column. So it ranges from 16 to 56, sorry. You can see in the middle that is the highest value. But these are all in the order that they were recorded in. So they were in random order, basically. And just any old order, because that's how they were recorded. And then we see on the other side, rank order, you can spot that they're all from the lowest rank here to the highest rank at the bottom. So I've got a little definition here. According to Adams et al. 2010, rank order distribution means placing your data into an ordered list from the lowest to the highest in a single column. So this is a good way of organising your data because it's easy to interpret. You can quickly see which is the lowest rank, which is the highest rank. This is also useful in sports. So say if you had basketball, gymnastics or football, say if you had leaderboards for the top scoring teams or individuals, and people wanted to see who's the top, who's the bottom, they could easily see, at the top there's whoever, or at the bottom he's there, whoever's there, they're obviously losing, and who's in the middle and stuff like that is easy to interpret and to view. Moving on, the range. This is another way of organising your data. So this is you would rank order your data, and then you would find the lowest value and the highest value, and you'd subtract the lowest value from the highest value. Excuse me. So Adams et al. 2010 states that the range is the distance in the numerical value from the highest to the lowest value collected. So, for example, this range would be 41, and then this would be representative of the data set, for example. Some negatives to the range, though, if the data set is mainly comprised of small numbers. So say up to 56, all these numbers were 3, 4 and 5 maybe, it would mean that ultimately the range would actually be not representative of the whole data set, because you are literally taking the largest number and subtracting the smallest, and then you'd get another large number, and it would not be representative of all the small figures that were in your data set. So you have to be wary when choosing how to organize your data, because sometimes the range might not be good for a data set because it is mainly comprised of all small numbers, and then maybe one anomaly where something happened in the testing and there was a one large number, and it meant the whole data set was skewed. So you have to be wary of what you choose to organize your data. So last one, simple distribution frequency. So this basically means that for every value that has been recorded, a frequency has been also recorded. So you see 25 here. We can see that here 2 people scored 25, one person scored 46, so on. 3 people scored 27 on sit and reach. And this is not how many participants there are. So this number is not how many participants there are. This is the amount of scores that were taken. And then 2 and 1 and 3 are obviously the frequency. That's why it's in the frequency column. Basically saying how many times that value was scored by an individual or multiple individuals. So where the frequency is higher than 2, it means that this value has occurred twice in the data set. For example, for this sit and reach test, 2 people scored 25, 21, and 3 people scored 27. This can be useful in sports, in like sports such as basketball, maybe, where there's a lot of scoring going on, and then for each individual, they would have a frequency chart to say how many times. So, say LeBron James, for example, scored 15 2-pointers, 4 3-pointers. That would be an example of simple distribution frequency, because um, there's so in this column there would be the 3-pointers or the individual, and then in this column there would be the frequency of of what they scored. So moving on to presenting data. So presenting data is an important part of your quantitative data analysis study, because without presenting it in the correct way, it can mean that it can be misinterpreted if it's not clear enough. You could choose the wrong graphs, and it just doesn't make sense. Yeah, but the main risk is basically misinterpretation or incorrect showing of your data, which basically means that your study, when presented to other people that weren't involved in the study, that they won't understand what your results actually show. So this is a very important part of the process. So to start off with, we have a bar chart and a scatter graph. So when looking at bar chart, for example, we see that this is a chart for systolic and diastolic blood pressures and comparing, and immediately you can see that the red and blue values, which are indicating diastolic and systolic, blue being systolic, red being diastolic, that the chart itself is best used to basically view the difference between values. So bar charts are best used to show the difference in values in the data set, and is visually easy to read. And basically it means that you can see the difference easily, because visually you can see if one bar is higher than another. And obviously there are values for reference at the side, but usually if you took two values next to each other, so this basically shows the difference between two values. So looking at a scatter graph, this looks at the relationship between variables and can show there's a correlation at all. So this would be used for this. I've used flying sprint, standing vertical jump, and they did not have a correlation. We can see this as the values are scattered across the graph. They aren't in a line going from bottom to top or the other way, which would be a negative or positive correlation, which basically means they had a relationship. So that means that say if this did have a strong positive correlation, it would mean that standing vertical jump, people that were good at standing vertical jump were also good at flying sprint flying sprint. And that would be the relationship that you would see. So this looks at the relationship between variables and can show if there is a correlation or relationship at all. They're best used when the independent variable and dependent variable are both numerical values. So moving on to my next slide, I have a line graph. So here we have a line graph and a histogram. So the line graph, basically it can show a relationship and also how results develop over time, however not in this graph. So so we have the participants at the bottom and we have the score at the top, and it basically just shows for each participant. You can see that for number 2 they scored around 15, and then for participant number 3 they scored 20, and it's visually easy to see, and we can also see that these SD bars, standard deviation bars, have also been added. So